In this tutorial, I'm gonna show you exactly how I build these twisting tower prototypes in Blender using geometry nodes. If you're new to geometry nodes, don't stress. It's gonna be a beginner-friendly step-by-step walkthrough, so you will understand what each and every node works, why it's there in the first place, and which role does it play to modify the geometry that we're working on in a 3D viewport. By the end, you'll have an understanding of how the node tree works and how it modifies the geometry we'll be working on. Let's get into it. The first thing we need is a plane. Press Shift here on the 3D viewport, go to Mesh and select a plane. With the plane selected, switch over to the geometry node workspace and add a new geometry node modifier. One habit that keeps my project clean and easy to manage is the fact that I name each and every node tree that I work with. So I'm gonna name this one Tower 2. And the reason is that it's super useful when you start to work with multiple procedural models in the viewport. After that, click the pin icon. This pins the node tree and keeps it active when you select any other object in a viewport so that you don't accidentally lose it while working on the model. Now that we are inside the geometry node workspace, you'll notice that we have two nodes connected already. Group input and group output. Think of these like the beginning and the end of each and every geometry node tree. The group input brings in geometry from our object, in this case the plane, and then the group output outputs the modifications of that geometry. So that means each and every node that we put in between these ones, these two, it will modify the geometry that we're working on in a 3D viewport. Press Shift A, search for cone. You can go through the drop down menu, go through the mesh primitives and find cone. After putting it there in place, a quick shortcut is to hold Shift Out and click on this. The node will just connect to the group output. Notice what happens in the viewport. The plane has disappeared and now we have our cone already. That's because we are no longer using the plane's geometry, we are now using the cone. Instead, the node tree is generating a brand new mesh, the cone, and sending the data to the group output. Let's adjust a few of these properties. First, increase the depth. This controls the height of the cone for this tower in case. Next, increase the bottom radius to 10 meters to give the tower a wider base. Now I'll change the vertices from the default value to 4. Since the cone now has only 4 sides, it will become a pyramid instead of a smooth circular cone. Finally, I'll increase the top radius to 5 meters. This truncates the tip, and I'll set this height at 40, and 40 by 3, that's roughly 13 stories. It will be a better starting shape for our twisting tower. Now it's time to make the geometry twist. How are we going to do it? This time around, we have a few nodes that we are going to put in here to make sure that the geometry twists in the viewport. And the nodes we are going to add are the ones that are going to be modifying it to twist. Press Shift A and add a set position node in between the corner and the group output. The position node changes the position of each and every point in the geometry. So as you're seeing our pyramid, each and every point is now having a different position. It's no longer read as full geometry. By moving individual points, we'll be able to bend and twist our shape. To tell these points to move, now we're gonna add a vector rotate node. This one node that is going to rotate or twist our tower. The vector rotate node takes in a vector and rotates it around a chosen axis by a specified angle. I think you understand that we have to rotate our geometry around the Z axis, this vertical axis, by an angle. You get? So that means we're gonna rotate the position of each and every point on this mesh. I think you're getting it. So that's why we put a set position node in the beginning. So if connected, the geometry disappears, but don't be scared, that's a normal thing. And what we're gonna do is to add a position node. So when you connect the position node to the vector input of the vector rotate node, what this does makes our mesh come back. Why? The position node outputs the x, y, z coordinates for each and every vertex. That's why our geometry reappears in the viewport. So the next question is how much will each point rotate? If you rotate each and every point by the exact same amount, the tower will just instead spin like a solid object, and that's not what we want. To achieve that, add a separate x, y, z node. What does this node do? Separate XYZ node splits the vector into individual X, Y, Z points instead of a wholesome coordinate XYZ. So to help us choose the axis we want, in this case we would need the Z axis, because that's where we're gonna rotate our structure. So connect the Z output into the angle of the vector rotated node. Now the rotation angle depends on each and every point side. Points near the bottom receive a smaller rotation, while points higher up receive a larger rotation. Instead of the whole object spinning all together, the geometry just twists progressively from the bottom to top. Press Shift A and add a map range node. It remaps one set of values into another. In our case, we are taking the height values of the tower and converting them into rotation values. Without this node, the rotation will be uncontrollable. Next, create a copy of the position node and connect it to the vector input of the separate XYZ node. Remember, the position node outputs the 3D location of each and every single vertex on this geometry. So let me go back to the cone node and increase the side segments. Side segments control how many vertices we have on each and every edge. At this stage, the twist may look like it's a little rough, and that's because the geometry doesn't have enough resolution. Now let's create the balconies. Add a mesh to curve node. It converts the edges of our mesh into editable curves. So these curves will be used to generate balconies. After that, add a curve to mesh node. And this node will give our curve some thickness using the profile along its entire length. Right now it doesn't have any profile, so nothing appears there, right? I'll set the scale value to 0.01 so that it doesn't disturb us in the 3D viewport. Next, add a join geometry node. This node simply combines multiple pieces of geometry into one final mesh, and you see how useful it is. One branch will contain the tower itself and another branch will contain the balcony geometry. I'm going to introduce a quadratic Bezier curve. For this one, I will just explain in the next tutorial how it works. But for now, I'm going to edit it to create a flat surface as our balcony. So let me go back to the cone node and increase the side segments. Then I will adjust the endpoints of the Bezier curve. I will increase its X value to around 2.5 meters. This is creating a balcony that is cantilevered to roughly 2.5 meters in real life construction. Now play with these values in the map range until you get a twist that you feel like. And you can also change the interpolation from linear to smoother step. Now let's assign the material. Add a set material node before the join geometry. The set material node doesn't create materials. Sim tells Blender which existing material should be assigned to the geometry passing through the node tree. Finally, let's improve the facade. Add a subdivide mesh node, and this one will help us create our facade and curtain walling. The subdivide mesh node inserts additional faces onto the mesh, giving us a final mesh to work with, as you hear the name subdivide mesh. So let me first switch to our frame view. You notice that the facade contains a little more faces. If you increase the subdivision level to around 3, the more the faces you will see appearing. This creates a much denser grid on the facade, which is perfect for developing a curtain wall system. Now add an extrude mesh node. It creates new faces by pushing the faces outward or inward. I think you understand that. So I'm going to increase the offset scale until the facade begins to project outward. So these small offsets create depth needed for curtain wall panels and architectural detail. And that's the entire procedure setup. Let's quickly recap what every major node did. Firstly, we put a set position node, gives each and every vertex its individual position in the geometry. Then the position node outputs the location of each and every vertex. Separate XYZ node, splits the position of XYZ coordinate into individual XYZ points or vectors. Map range, it converted the height values into controllable rotation values. The map range helped us control the rotation by converting those heights into rotational values. Vector rotate node, it rotates each and every vertex along a given axis. Mesh to curve converts the mesh into curves. Curve to mesh turns back the curves into real geometry, which is mesh. Join geometry, combine multiple geometry nodes in one stream, as you were seeing. Set material helps us assign material to the geometry. Subdivide mesh adds more geometry and makes it look smoother. And lastly, the extrude mesh node, it gave our facade depth by pushing faces outward. Subscribe to the channel